All right. So my project for this semester was an independent study. I titled it "Population Survey of Corbicula fluminea in the Finger Lakes Canal System: An Investigation of Lake Sturgeon Habitat." So got a picture of me doing some sampling, and you'll see more about that. But real quick, who here knows what corbicula is?
Clearly not me.
Yeah. Well, okay. So I kind of figured that. The common name is the Asian clam. It's a pretty small freshwater mollusk. I'm going to rip through this stuff because I don't run over it. Basically, their habitat, they like sandy sediments, so similar to what we have in our lake. Fairly shallow water from 2 to about 40 meters. They really prefer about 3 to 10 meters, which is what we have in the Seneca River and at our north end of the lake where it's fairly shallow. So they like temperatures from about 2 Celsius, so near freezing, to up to 30, so it's a fairly wide range. They're not super picky about that. Reproduction, they're hermaphrodites, meaning they can switch sexes. They can reproduce sexually and asexually. They produce up to 68,000 young per year, which is a pretty stunning statistic. One note, just kind of keep in mind, they only reproduce at about 16 degrees and higher. That's about 60 degrees Fahrenheit during the year. And their diet, they're actually kind of unique in their diet. They can switch. So zebra mussels and quagga mussels, I'm guessing you're familiar with? Yeah, a little bit at least. Well, what they do, they grab onto something and just filter the water. So corbicula can do that, and they do if there's nutrients in the water. But if there's not nutrients in the water, they have the ability to go into the sediment, so into the muck at the bottom, and pull the nutrients out of that. And that's also going to be kind of key in the future. So they're not native here. They're an invasive species, and they're exotic, native to South Asia, a little bit in the Mediterranean and Australia. They were introduced by the Chinese on the west coast as a food source. I don't know why you try to eat them, they're nasty little guys, but and as bait, they make really good fishing bait. They were first found growing naturally in the United States in the Columbia River Basin in the late 30s. And the next 40 years kind of made their way throughout all the major river systems in the United States, all the way to the Atlantic coast. They made it into Seneca Lake. Well, I'm not sure when they made it in, but we found them in 1999, about halfway down the eastern side of the lake, near the United States Power Station. And we have them on the northern end of the lake, where Castle Creek comes in and Geo. So they're definitely there. So why do I want to study these little buggers, I guess? I guess this simple answer to that is lake sturgeon. Would you ever know what lake sturgeon are? Okay. So I'm holding one right there. As you can see, it's a pretty substantial fish. They're monsters, actually. They're pretty harmless, though. They're bottom feeders, really long-lived, and they can grow to 120 years pretty easily. They're bottom feeders, very primitive. They've been along a long time without evolving. And they were once a really key part of the fish community in the Finger Lakes. They're native, and they've been here a very long time. But after 1961, no one saw one in Cadoga Lake, which led scientists to believe that they were, the populations were dwindling. Yes. So in 1995, New York DEC began a stocking program in the south end of Cadoga Lake. Basically, they would introduce young and allow them to grow. And so that went through 2004, and in 2005, the USGS, the U.S. Geological Survey, began basically gill netting. So they put a big long net across the river, and any big fish that swims through gets caught. Then you go out and pull the net out and check. So they began seeing some real flourishing adults. So this is an indicator that the population is coming back, which is a good thing. So where does corbicula come into this? Turns out, although they're invasive, they create a really good food source for lake sturgeon. So my project focused on whether lake sturgeon could have a suitable habitat in the Seneca River, right here. So we're here at northern end of Cadoga Lake, little zoomed in area. And this leads down kind of this way. Seneca Lake is right here. So if there's suitable habitat there, there's a potential for lake sturgeon to move from Cadoga Lake through the canal into Seneca. actually, for a viable population of Corbicula then, so that's what we're looking for if it's going to be a viable food source. We want an adequate population density, which is going to basically imply that there's enough food source and suitable habitat for Corbicula. So we're going to have a good density, and we're going to have a reproducing population, so evidence that they're reproducing and flourishing. So this is what I did all semester. That is a benthic Honar grab sampler. So basically you lower it down into the water, give it a jerk, and pull it back up and grab a bunch of the muck from the bottom. You sift it, put it in those yogurt containers, and that's basically what I did, was sort through those. Just looking through, picking out any Corbicula. I also picked out zebra mussels and quagga mussels for later analysis. But basically, this is what I ended up with, a bunch of these guys and a bunch of dead shells. So what do I do with that? What I have here is a graph of the densities of zebra mussels, Corbicula, and quagga mussels in the Seneca River and the Clyde River, which is north of Cave Lake. So the major things I want to pick out here are generally low densities of mollusks in the Clyde River, nothing really over about 60 individuals per meter squared. And then I want to contrast that to, especially this, live Corbicula at over 130 individuals per meter squared in the Seneca River on average. In addition to that, there's a lot of zebra mussels and a fair amount of quagga mussels in there as well. So there's evidence that it's a pretty strong population. There's food, they're flourishing. It's a good sign. So reproduction, are they reproducing? It's kind of hard to tell, but what I have here is the size distribution of the clams, the live clams I found. So what we have, see this kind of large bump in the data right there? That's what we call a cohort. So that's like almost a generation of clams as they're born. And what we can infer from this, you see this range from about 4 to 9 millimeters. And in November, the following year, or I guess the continuous year, you see this grouping around 10 to 14. So that's the same cohort, 7 months later, or 6 months later. So I infer that that population is growing and maturing into a reproductive population. And then you also get this large spike right here of these 2 to 5 millimeter individuals that are much smaller than the ones in that thing, the sample. And that's a new one. So that's evidence that they're reproducing. So it's good. Check. There's enough food, they have a big population density, and they're reproducing. So they're here. So what are the implications for Seneca? That's the real question. There's positives and negatives. Generally, invasive species are thought of as a bad thing. We don't want them here. But there are some positive aspects. In our case, they're going to reduce the nutrients in the water. So Seneca is right now experiencing some pretty serious nutrient loading from surrounding agricultural land and waste treatment plants. So they actually filter water, take out all this nutrients, and deposit it in sediment. And obviously, they're going to produce an awesome food source for the sturgeon as well. There are some negative effects, possible effects at least. When there's really clean water, low nutrient water, as I said, they go down into the sediment and start feeding off that sediment. So what happens is they're pulling nutrients out of the sediment that would otherwise just kind of stay there, and they're putting it back into the water. So in clean water situations, it's a big detriment, and they actually add to nutrient loading. That nutrient loading can create algal blooms, and I don't know anyone in here that really likes swimming in water with algae in it. Maybe. And in addition, they're going to reduce the native phytoplankton and zooplankton that is a good food source for native fish and organisms. So that'd be a pretty strong competitor against them. So there are eradication efforts going on around the country right now. The most prevalent right now is in Lake George. Anyone know Lake George, New York, eastern New York? They're really oligotrophic, so clean water, low nutrient lake, very touristy. A lot of people like it. A lot of boating, a lot of swimming. So what they've done is take these massive plastic sheets and scuba divers, and they go down where these clam colonies are, and they spread them out and basically suffocate them and starve them to death. And they're achieving almost 100% mortality with that method. And then in some smaller, kind of more confined areas, they're trying to do this suction harvesting, which basically is a big gas-powered aquatic vacuum cleaner. They go around and suck them up, but that really didn't prove too successful. They thought it was aiding in their distribution across the lake, so they're stopping that. Lake Tahoe, I'm guessing you all know, is a really similar experience as far as like lake-wise. They're getting just a few corbicular right now, but they want to nip it in the butt really quick because of the same reasons. Algal blooms, no one wants to be in a lake with algal blooms, so very similar project. And then to bring it back to the Finger Lakes, we have a Wasco Lake, which is a corbiculate been discovered on. And what they tried to do was lower the lake level to hopefully freeze them out, get the water temperature below 2 degrees Celsius and limit the population. But as we all know, that really didn't work out this winter. Not only did it not get cold enough, but there's no snow melt to fill it back up, so they're kind of fine. So real quick, I'd just like to thank Megan Brown for her support and the USGS, especially Don Dittman, who gave me all the materials and sampling opportunities